Okay, so I was wondering, for the development of the actual hands-on, while we wait for others that's still coming back, did everybody have a chance to follow the instructions that were provided with the email? Yeah, because the thing is, see, there's a series of steps here to successfully build the application, get it on the board, and actually get it to communicate over Bluetooth with the phone. And the key thing here would be to have at least that everybody has the code base, so Zephyr itself, and the toolchain working. So is there anyone who is trying or has tried to get the code base down and the toolchain working, and it's not working? It hasn't managed to make at least Blinky work on the dongle. You haven't, okay? Because we'll get to that one by one, but just to get an idea of how many people need assistance prior to the actual development of the hands-on. Because here, yeah. Can you put it in, Jared? Can you put it in the Discord channel that we have? So I recommend, as part of the email, we'll also send you a link to a Discord server, and inside the Discord server there's a channel. 2022 OSS EU that Jared is writing to now, as you can see here. I don't know if it's very visible now, but the point here is not for you to see this on the screen, but rather for you to be able to have these instructions handy if you're going to try to make this work now. So to get into the Discord server, really you only need, as long as you have a Discord account already, otherwise it might take a while, but it's just chat.zephyrproject.org. So chat.zephyrproject.org will send you straight to to an invite, or rather to the URL, to the vanity URL for the Discord server for Zephyr, and that's the simplest way to jump on and have a common place where to copy and stuff from. Okay, so yeah. So first, let's give people a little bit of time to see if they can jump into Discord. If you are going to follow these instructions, that's the easiest by far, just being able to copy those. And if you have tried already to make Blinky work and you haven't managed to, then please raise your hand like the gentleman did, or make yourself known, so we'll try to help you. Okay, so let's begin by trying to help out the people that have tried and so far haven't managed. So I'm going to turn my All right, can you hear me? Yeah. Okay, so this dongle doesn't come with a debugger chip, okay? And that means that using West Flash is non-trivial in this case, so we're not going to use West Flash to flash, unfortunately. This is the board we had available. Most boards do support West Flash, but this one doesn't. So instead, so in this particular case, what you're seeing now here is the steps to get the actual application built. Now, in order to get it to into the board, I'm going to paste them now here in this Discord as well. So that you have, and you need to install. First, let me just here. P3 install. Assuming you're on. Well, let's leave the user out. Util, and then there it is. This is a bit unfortunate. I apologize for that, but it's the board we had that the vendor donated. In this case, my company. And it turns out that this board doesn't come with a debugger chip, so you need a special. Oops. There we go. And then. Okay, so to the gentleman I was talking to a minute ago, the procedure in order to get the binary into the board is to install the small NRF utility from Nordic, just with pip, and then you have to generate this package using this command, and then after that, with NRF util, you invoke the DFU option in it with USB serial, and then the package, and then def and port. Now, we could have, and we should have, in fact, implement this as part of a West Flash command. We should have done that, but it's not done, unfortunately, because, and the reason we haven't done that is that this board supports many configurations, and this is one of them. And Westflash couldn't. We don't have a mechanism to tell Westflash which configuration you are running on, so that's why we didn't do it. But it would have made sense anyway to at least do it to some extent. So okay, so there are two things here. So the second part, the part where it says install Init Util and so on, that's just to get any app into the onto the board. But then there's this app that has been specifically written for this session today by Jared, who is here, and that app is the one that you can see in the first one, in the first block. These are the instructions to get the app. Okay. To obtain the app from GitHub. So for those going over again, first for the Blinky part. So getting the Blinky part, which was the sort of quote unquote the work you had to do at home. Is there any other people that need assistance with that, with the Blinky, getting the Blinky to work? Sorry, yeah, build first, build. Okay, so everybody can build Blinky in general. So then I suggest that we give people, in general, folks, a little bit of time to try and get that Blinky onto the board using these commands here. Okay. If you have any issues at all installing Init Util or making it work, let me know, please. Okay, as usual, there's some hiccups. So anybody else with an ARM or non-x86 based laptop needs to follow this additional step in order to get this part to work, the Init Util part to work. Okay, so I'm going to paste it now here. I need to go to this one.
Is that the normal Zephyr chat? Yeah.
It's just the fact that Nordic hasn't edited or hasn't updated this tool in a while, so it doesn't have support for ARM-based computers. So for ARM or for non-x86 basically, because this is based.
These are the same steps as they were in the email that you sent?
Yes, they should be. No. They're not?
No, not at all.
They're not. All right. Okay, that's that was.
So
Yeah, no, I believe you. Okay, so what was the difference in the building or in the flashing?
Now the flashing is not there, if I'm correct. So only the building is there, so that you get the package. Then
I see.
you need the flashing, and then it's actually where actually is the zip file, for example.
Okay.
Well, in the email you build the Blinky app,
Yes.
and this is not that.
Correct. Yes, that's correct. Yes, that's the new. That's why I'm saying that the Blinky app was there to kind of set up your environment, and then we're going to use this app to actually demonstrate it today. Okay, that was the idea. But if that's why I'm asking if everybody got the Blinky app to work, and then once we get that Blinky app that moved into the board, then we can move into building another app, if everything works. But that's the idea. So. Has everybody been able to move the Blinky app, build it, and move it onto the board or not? Or is there issues?
move it into the board, but
Flash it into the board.
just build it.
Okay. Can you try the instructions to get it onto the board that are described on the Discord page? Sorry, let me try to clarify this a little bit better, because I understand it's a bit confusing. Yeah, the port will look different on every computer typically. Ja esborra el teu missatge, copia-te'l i esborra'l, vale? L'esborro, me l'esborro jo mateix. Perquè si no ens estem confonent a la penya. Ok. just to clarify, make things sorry for the confusion. I removed the earlier message. Let me remove this one as well, just to verify. Let's do things step by step. Let's get the Blinky on everybody's board first, okay? And then once that's done, we'll move on to something else. So those are the instructions on the Discord server. Once you've managed to build Blinky, to move it, copy it. Great. Okay.
Possibly one more.
Great. Okay. Good. All right. I'll give people a couple minutes, and then in the meantime, what we can do, Jared, if you think before trying to move on to something else, let's show a little bit how this Blinky works and ask people to modify it, and then. So. Yes, of course. Perdón, ya pasó. Yeah. Okay. Good. Great. So because devices in Zephyr are described in device tree and parsed at compile time, as I described in the earlier presentation, one thing is to have the device present in your device tree. Another thing is the device is actually working or even present at runtime, of course, because the build system cannot know what goes on at runtime. So that's why we have this call device is ready. It's essentially telling you, okay, from this device that we've defined as, if you can see here, let 0 node DT alias let 0, this device, is it ready for me to start using, right? Is it ready or not? And a small interjection here to explain a little bit about Zephyr and device tree, a little bit more, is that the way everything is processed in Zephyr is that the device tree files are parsed by a Python framework toolkit that we have that's part of the Zephyr project, and then a series of macros are generated during build, and then there's a macro-based API, one member of which is this DT alias function here, that allows you to retrieve information from the device tree at compile time, basically using that API plus the generated files that have been generated from the device tree source files itself. So here, when you do let 0 underscore node, which converts, as you can see, to DT alias let 0, this in fact maps to the overlay, to the device tree overlay that we've created as part of this app, or if the board has it already, which essentially gives you the node whose alias is let 0 in your device tree, and all of that at build time. So once you do that, once you have that DT alias, that's just a reference, and then to actually get the device pointed to the device itself, so you can start using it. There's some utility functions. In this case, well, they're always named DT underscore spec for all the types of peripherals out there. This is the GPIO one, and it allows you to obtain, fill in this structure based on a let 0 node, and that from there you can then start invoking normal APIs, having obtained the pointer directly using the device tree macros, the device tree access macros. Any questions regarding this? Because it's pretty important in Zephyr. This is the foundation on how hardware access works in general in Zephyr. It's all very well described and documented in the official documentation. The maintainer of the device tree subsystem does a very good job maintaining documentation, but just to understand. So these are all, obviously, these pointers and these structs are all filled in based on information available at compile time, hence line 26. So once we have a handle to the device, which is the GPIO device, and we know it's ready, we can configure the pin as output. And once that's done, we can toggle it using a standard GPIO API, and then sleep for a predefined amount of time, in this case in milliseconds. So just as an exercise so just to make sure that everything is working fine, you could reduce this 1000 to 100 and then compile again. So as usual, you would do NRF 52840 dongle. NRF 52840. Oh yeah, thanks. Dongle. There you go. And then samples, basic blinky. Go. NRF util to generate the package, just exactly the same as we did before. And then NRF util. This is just I'm just executing the same command that you have in the on the Discord server that they've been exercising now. And I think, yeah, okay. Obviously it doesn't work. Let's see, TTY star, TTY.USB star. Okay, it changes every time. Yeah, forgot that. macOS is like that. Okay, for this to work. There you go. So now in my case, I have the LED blinking at 10 times the rate. Okay, it's just an exercise to make sure that everything is working for everybody.
Can you bring up the command line to build again?
Sure. Yeah. Absolutely.
Maybe scroll up to the top.
Yeah. I'll just 1 second. Clean, and then clear. So to build is this one here. Right, so west build -p for board. If you've enabled auto completion, then you can type NRF 52840 and then press tab, and it should bring up the boards that begin with that name, and then the path to the application. In our case, samples basic blinky, and then the rest is what's on the Discord server about flashing. And then in the case of macOS, because the name of the serial port changes every time you plug in, and then you have to actually ls and find it. It's a bit, but other than that,
Sorry, just a question. Because
sure.
after flashing, I don't see the serial port again appearing. I mean, the program is running on the board, but
Okay, yeah. Sorry. In order to flash, yes. In order to flash on this board, yes. Sorry, there's so many tricks on this board. It's because, you know, we should have been brought boards with a debugger, huh? Because those boards without the debugger are really complicated. Sorry about that. There's a small button on the board that allows to enable the DFU bootloader mode, which is required in order to get the firmware onto the board. If you see it, it's just next to the main button, but you have to press it sideways. You see it? It's really tricky. You need a little bit of a nail to get it, yeah? And then you should see fading red pattern, and that means that the bootloader is on, and then you can execute the NRF util DFU USB serial. Here, I'll show you. So you see that one here?
This one.
Yeah, it's minuscule. There you go, just press it. No? That's weird. Okay, see? Yeah.
Yes, thank you.
Yeah, and now you should be able to execute NRF util DFU USB serial.
Thank you.
Sure.
Yeah, it works.
Yeah? Good. Now, it is unfortunate, like I was saying, that this is not the simplest of boards to work with. In general, most development kits just require you to do West Flash. You don't have to press a button. You don't have to invoke an external tool. But this is the hardware that was donated, so we have to work with what we have. So anybody need help with this iteration of the exercise? No? Okay, good.
Just checking, is NRFU not supported by West Flash? Or?
Exactly, it's not. It's not, unfortunately. And I was saying earlier that the reason it's not is that this board actually allows a myriad of configurations. So you can either solder a debugger, not solder the debugger directly on it, but there's a pin header that you can solder and then connect a debugger like Seger. J-Link, you can connect J-Link into it.
This one doesn't have a J-Link
Correct.
like the big NRF developer.
Correct, exactly.
So we are flashing over the USB from the DFU.
Exactly, but it's not standard USB DFU for other reasons, and that's why you need NRFutil, right? And the reason West Flash doesn't support NRFutil is multi-pronged, but the main reason is that, like I said, this accepts a lot of configurations, and West Flash by default having NRFutil wouldn't be that useful, so we ended up not implementing, and that was clearly a mistake being that here today. But we'll learn from this. But it would be trivial to add a runner. We call them runners in West that implements flashing just by running NRFutil. Okay, it's not done. All right. So the next step, if everybody is now up to speed with Blinky, was to try and show you something a little bit more, something that can serve you as a starting point for your own Zephyr applications, based on this dongle or anything else. But now that the hardware is working, the idea is Jared here put together an application that can serve as, there's two purposes to this application. Purpose number one is take advantage of the ability that Zephyr has to help you structure your application and pull in your dependencies. That's the first one. So it's a repo management type exercise. And the second one is that the application actually does quite a bit more than just the Blinky. So it sets the RGB LED to of the board. It's actually RGB, even though we're now using it without PWM. It does so based on the input it gets over Bluetooth Low Energy from a phone. Okay, so we're gonna try and get that done. Now, is everybody on the Discord server? Is there somewhere else you want me to paste the information? I think Discord is the easiest way for me to broadcast instructions to you. But if you have any ideas, then let me know. Sorry, can you say that again? Oh, the invite did not work. Damn it. Okay, one. Where could we? There's a link, yeah, but if the invite did not work, even the link wouldn't work. I can create a gist if you want, a gist, and then give you a URL to the gist for those of you that haven't been able. So Jared has now created this section in the Discord that says Smart Light Bulb Demo. So I'm going to copy that into a gist. Okay, gist. Someone has a better host for this code, I'm fine with that as well. Just let me know. Otherwise, I'll just use GitHub. Okay, so create public gist, and that is. Oh my, this is pretty long, huh? But anyways, hopefully it is visible, the gist URL. Anyone knows something better to remember? Oh yeah, we can do a URL shortener. Yeah. I'm going to bit.ly will do fine, right? And there we go. So it should be fine. Shorten your link. There we go. All right, so there we go. It should be better.
Can you get a QR code generator?
I'm gonna paste this one on Discord for those that want to come take it. But basically, it's bit.ly 3D8T0AA. Okay, this one should be easy to get to. And then I'm gonna navigate. First of all, I'm just gonna people 30 seconds to get the page open, and then we'll navigate you through the instructions. That way, even if you don't have Discord, you should be able to get the to be able to copy paste. Because the important thing here is to be able to copy paste. Yeah. Does it work? I mean, any issues? Not for you? Okay.
Oh, this one. Yeah. My bad.
Okay, good. Oh, sorry. Yeah. Okay, good. So this is a demo, like I was saying, that allows you to control the RGB LED via Bluetooth Low Energy app. Now, because the getting started instructions that were sent to you include creating a Python virtual environment, and because you already created one before for the Zephyr one, we'll need another one. And the reason for that is that the and I'm going to take the opportunity to show you something here. The reason is that this application that Jared put together is based on what we call the example application. And if I show you what's the manifests here, yeah, there we go. Sorry, trying to find the topologies. Sorry, give me a second. Should be here. There it is. Okay, that's what I wasn't looking for. So the example application is a special repository we keep in the main GitHub organization that tells you a little bit about how to develop your own application without having to fork Zephyr, without having to do anything on your own. So, or rather on your own, without having to modify the Zephyr tree, without having to put your application inside the Zephyr tree, and so on and so on. So the idea here is this one here. That's what I wanted to show you. So the West workspace will contain your application as the main repository. So the manifest repository is actually your application repository. Okay, so it contains whatever you want. In the case of this application in particular, it will have a board, some drivers, and so on, and then your app itself. But then the manifest, and finally, even though it might seem a little bit counterintuitive, Zephyr is pulled in as a module. So you are using the West meta repo functionality in order to create a forest in which the center tree is your application with its own manifest, and then that tree imports Zephyr as a module, so you can use it, but you don't care about everything that comes in this area here. All of this is managed by Zephyr. All you care about is your own application and your manifest that pulls in Zephyr. Okay, and that's what Jared has done. So following this example, so this application, which you can see here, and I'm going to get to the instructions almost immediately, but this is based on the example application. You can see that it was generated because it's a template. And if you look at the manifest for this, it's extremely simple. It just tells you, okay, I'm example application. I have extended my own West commands. I have one remote, the Zephyr project, and this line here says import true. Which what I'm saying is, okay, Zephyr has another manifest, and I want West to import it, which means that it's going to pull all of the dependencies that Zephyr has in its own manifest. It's going to do that, but it's going to do that from our own manifest. So we have full control of the manifest. We have full control of the application. We don't need to modify anything in the upstream Zephyr tree, or even fork Zephyr at all. Right? Our app will pull Zephyr just because we've described the manifest like this. Okay. Any questions to this? Because this is fundamental to understanding the.
So does our West YAML file reference this?
So that is your West YAML file. That is the West YAML file of the OSS EU 2022 Zephyr app. Okay, that is the. Now note that import it's extremely powerful. You can import just by saying true, and it will import everything. But you can imagine that you have an app that doesn't care about certain functionality that Zephyr provides. You can actually import a subset of the modules that Zephyr contains, right? So it's very powerful, the import functionality. Okay, so moving on then. So these are hopefully you have access to the instructions now, and hopefully you can start following them and let's get to the point where everybody is about to execute a West update, and it's very important at that point for the West update that you include this -- path cache. This is because the connectivity here is relatively slow, and if you have to clone here all of the modules that come with Zephyr over this network and we do it all together, we're going to choke it. So instead, you can use West supports using a cache, and because you already have done that, because you just built your Blinky and you did that using an existing Zephyr installation, so then you can point to that Zephyr installation that you had using path cache, and then West will use that in order to avoid doing all the traffic or generating all the traffic over the internet. Okay, so I'll give you guys a few minutes to try and get to the point where we get this app working. I'll do it myself as well. So I'm going to do it step by step, so that if there's questions, we can. So I'm going to go to the main tree. My main folder. Just create ops source, and then this is. The cache thing doesn't work. What error did you get?
It's coding with 100 kilobytes from the internet.
Oh, okay. Hold on a second.
Just did it here. I do get an error. It says unexpected argument path cache.
Which West do you have? West version, please. And if it's old, should be up to.
Because I was using West Init path cache, but it's update.
It's West update.
West update dash path cache. My West version is 0.10.1.
0.10, yeah, that's too old.
Okay.
Can you update your West, please? And this error here, it's pip3 install -u capital U West to update. And let's take a look here. This issue with the. Can you help me, Jared, as well with the? Because I'm not sure about the path cache problems.
Initializing?
West init -m. That's fine. Yes. Already initialized in home. Boris. Oh, that's because you are inside Zephyr project. You cannot initialize a new workspace inside an existing one. Get out of Zephyr project and.
Run it again.
Yeah, exactly. That should work. Exactly.
Yeah.
Yeah. Okay. Let me see. Can I see the command?
So here's the
What's
command.
the date -- path cache? Yeah, that sounds perfectly
No,
correct.
Zephyr is not cache, so maybe we cannot copy manually Zephyr
Ah,
because it's not part of the. Yeah, because this is an application.
right,
it's not a
right,
module
right,
in
right,
the
right,
Zephyr
right. So
itself.
Zephyr itself is not being cached. That's, I think, the problem.
Okay.
Yeah, that's why it's going slow. So the other repos will work, but this one will not. That's a bit of a that's a bit of a bummer. Yeah.
Can you point at a local copy?
Yeah, that's what we're doing here. Oh, for Zephyr itself, you mean? Yeah. Yes, but because of the way path cache works, I'll get back to the author with that. But because of the way path cache works, it'll cache or it'll use everything else except Zephyr, because Zephyr in that case is the manifest repo. So in the first installation you did for Blinky, Zephyr is the manifest repo, and that's the one that the path cache doesn't look at. It just looks at the projects. You see, whereas the difference here being that in the new application, for us Zephyr is a West project, and in the original application Zephyr is the manifest project. That's why we're getting that. Now, how to get around that? Because everybody's going to be stuck at that 10%. No, actually, this one is going a little bit faster. You sure yours is not particularly stuck? Does yours? Yeah. What about yours? Is it moving? Yeah, it is moving. Okay. Okay, all right. Hopefully, can you try restarting in your particular case, please?
Okay.
Oh, well, it is moving, so.
It's moving, so.
The option you have also is to take Zephyr from the folder, from the original folder, and copy that locally into the new one. So from Zephyr project, so CP. Let me do that on the screen, okay? But for everyone that needs an extra boost. Okay.
Man, it's gonna take a while.
Yeah, Jared is posting it actually now. Okay, thank you, Jared. Can you edit my gist? Or I'll edit it.
I've updated Discord, but you can update the keys.
Yeah. Okay. All right. Oops, sorry. Not this. Where are we here? Is it not editable? Oh yeah, edit. West Init. Why is this West Init? After line which one? After which one?
After line 14. It says before running the West up.
Ah, yes, yes.
Here.
Yeah. Okay. So we've updated the public gist because we've hit a bit of an unexpected case where Zephyr, in one case, is the manifest repo, in another case, it's the project, so it wasn't being used. The cache wasn't being used, so you can copy manually. Don't you need -r? No, because it's the folder, right? So you can copy it directly.
It's need to copy to the previous folder because you're already inside. It's --.
Come.
Because pan este show hem canviat l'example application, per tant s'ha de copiar.
Ah, vale, així, no?
Així, sí.
Vale, okay. Sorry, okay. Now we should be all set. All right. So I've updated the gist now. Okay. Anyone that needs help with this particular sequence? How are we doing? I'm giving. Hopefully, we'll get there with getting the new example application. We thought it was we weren't counting on the slowness of the network, but the idea was give an overview of those what we call out of tree applications, and this is one of them. That not only it's out of tree in the sense you use an environment variable to point it to Zephyr. Yes.
For me, I need to do cp-a because otherwise it won't copy a directory.
Okay,
So
cp-a, and that works. Cp-a,
Yeah.
and then West update works, or
Actually, just check.
CP minus
Alright.
R, actually.
yeah, -a or -r. Yeah, I'm not sure.
So -a does -r and preserve any other.
Okay, I see. Gotcha. So then.
on my distribution, that's not the default.
I see. Okay, I'll do that. I'll add that. Thank you. cp-a. There we go. Okay. All right. Good.
So if I'm using the Zephyr as a module for my application, can I fix it on a branch or?
Yes.
For me, because
So-
I don't want everything to move because I'm
Yes.
developing,
So if you look at the line that I'm highlighting now, you can see here revision is main, but this could be a SHA, this could be a tag, this could be a branch, anything. Well, it is a branch now, right? But this could be a SHA or a tag.
Okay, so I can put whatever I wanted to make sure it's
Stable, and it won't move there for, ever. So if you look at, in fact, at the example application that we have in the the example application that we have upstream, right? This is the default one, the one that Gerard used to develop his application. If we look at the history, this, for example, when we released v3.1, we modified this to point to revision v3.10. If you do that, then obviously, then from there on, no matter how many West updates you do, the West will always be the same. Whereas, and this is an important difference, when you point to a branch, every time you do West update, that branch will be updated with whatever is on the remote, okay, every time. So what you get is whatever is in there at the time of launching West update, which obviously is not desirable in many cases. And that's why you can set a tag or a SHA instead of a branch name.
and it will override the update. Oh,
It will always respect. So if you were in main first and then switch right 3.10, it will go back to that. If you had changes or a branch in the actual locally, it will warn you and abort if necessary. Okay, so it does take that into account. Okay, going back to the gist. All right, how are we doing back there? I know we're. Are we? Is it moving forward?
Faster. Now I have some rights problems, but fine.
Okay.
But how would you handle a situation where I'm adding my own board, my own proprietary board?
That's exactly this.
That code goes into your repo, into the Zephyr repo, right? It's not out of tree.
So it depends. So you're talking about having your own board that you want to submit upstream, or that you want to have on your own.
I have it on my own.
Then this repo is a demonstration of exactly that, an out of tree board.
Oh, wow.
So either one. Remember that example application is a template repository, and OSS EU 2022 Zephyr app is an instantiation of that template. Okay, for this. So if you look at the OSS EU Zephyr app, there is board's ARM custom plank board. Okay, this board will be detected automatically by the Zephyr build system because it's located at,
Okay, under the boards directly.
yeah, exactly. Okay,
It will kind of overlay.
correct,
with my,
correct. So then when you build, you can specify this name, custom plank, and it will work all the same, even though it's not part of the Zephyr tree. The way this magic happens is that every single module repository must have a Zephyr folder with a module.yaml, and one of the things in that module.yaml is this here board root that it adds an additional board root to the ones that Zephyr looks for, right, as part of this repository. So Zephyr will parse this YAML file. We'll see that there's this board root statement here and say, okay, so I need to add the root of this repo to my list of board roots and detect the board. The same goes for DTS if you're making, for example, your own bindings. And the same goes for a kconfig as well, and CMake to get the module built and integrated to the build system.
I manage my entire project application and board as an external.
Correct.
Out of tree.
That's exactly the purpose of this infrastructure. So you don't have to ever touch Zephyr and its tree at all. Okay. All right. So are we more or less ready to start building, or? Still downloading. Okay. All right. And you use the. Did you use the cache, the path cache?
Yeah. I didn't want to stop it in the middle.
Picolib. Why is Picolib taking so long? This one should be already in.
Automatic.
Yeah, it should be. I don't know why. See.
I added CP--A.
Yes.
I can't copy a directory into itself.
Oh, it's probably because you're where you are. Oh, no, can you help Jata? Because I was called by the other gentleman, so I'm trying to do it in the order that. Yeah, thanks. Do you mind if I slip through? Thank you. Thanks. Thank you. Yes.
I was just trying to execute the build, but it gave me this error here. I don't know. I probably didn't initialize something correctly. We don't have these files there. I don't know if there is a step to generate them.
That's because you have a Zephyr based. You have set Zephyr base, right, to work with Zephyr. I'm not sure why. So can you clear?
Maybe I did this at
Before.
one point.
Yeah. Just do an unset Zephyr base and then.
Oh.
Zephyr base, yeah. It should work.
Like this.
Yes. And let's try. Where are you now? OSS 2022 example application. Yes. Now try OS. Try building. Delete the build folder, please, first, just to make sure that we don't. Yeah. And then try executing again.
West. This guy here. Right?
Yes, that seems correct.
Oh, now it's going.
Yeah, seems like it's working fine.
Okay.
Okay.
Yeah. No,
All right.
great. Yeah.
Okay. Good. Yes, that's the LED.
Yeah.
Oh yeah, there's tons of LEDs now. Yeah. I know. You're gonna have to get in. We're gonna get there. Yeah, we're gonna get there in a few minutes.
6 people mentioned.
6 people at least, right? Because you're seeing 6. Okay, that's good. Ah. Actually, that's one thing we're going to do now. Yeah, so I was doing myself. I'm just following the instructions myself. Huh? In my case, I have it in another place. Yeah. Source. That's weird. It's not path cache. I don't know why in my case it's also not picking at least every single cache out there. No.
Yeah, same.
Yeah. You also stuck there?
No,
yeah.
no, I'm done with that. I'm
okay.
building.
All right, okay. You know, another thing we should have done is do a name allow list on the filter instead of importing the whole of Zephyr, just filtering out because we don't need the HAL expressive. We're not building for ESP32.
Maybe show the one from the conference. So maybe just open the example application.
Quin?
A la conferència, el que vaig presentar d'aplicació. Obre github.com/pslabs/exam. Bueno, si vols, obre ja està. I si pots comentar-ho, perquè és que és la manera, tothom ho ha de fer. No vull, però... No, aquesta. Obre el West aquí. I això és el que has d'escriure.
Yeah. So this is the way you filter with West, in order to not import everything, which takes a long time. By just you just basically define a number of modules that you need, and then pull them in, which is probably. Jared, can you push this change to the? I think it'd be quicker for those that are not done yet. I'll wait for Jared to do it, then I'll just pull. I'm just waiting for Jared to push an update to the application that the OSS 2022 Zephyr app, one that will set a whitelist or an allow list, so that we don't have to. For those of you that are not done, this should speed up significantly. I'm going to do the same because I don't know why the path cache is not working for modules like HAL Expressive.
And then just restart the West update.
Yes. So once we've pulled that update that Jared will get now. Oh, by the way, I probably need to give. It worked for you fine? Yeah. Okay, then I don't know why exactly in some cases doesn't work. Let me just go there and give Jared access to this push access. Yeah, I need you know push access. Yeah, I'm gonna do that now for you. Okay, try now, Jared. All right, so you should be able to pull now from the example application, and now if we do West update, hopefully it will be fast no matter whether you're caching or not. There we go. So in my case, it was super fast. That's because, as I'm going to show you, I just ran West update literally. That's because Gerard added this patch here. Let's show the diff here. This is actually very useful because it shows the power of West when trying to import. You can so obviously Zephyr comes with all sorts, right? And some repos are massive. So we don't need any of those because we're building for Nordic, so we need Nordic's HAL. We need Seger for some debugging extras that Jared put in there. CMSys because it's the core ARM HAL. And then TinyCrypt from some crypto that is required for Bluetooth Low Energy. And everything else is in the main Zephyr tree. So we do not need all of the other extra repos. So Jared instead changed that import true, which is a blanket statement, import everything that Zephyr has, instead filtering by name. You can also filter by path, you can filter with regexes, you can do a lot of stuff with West and filters. Great, so hopefully, all I did, by the way, I didn't put in the gist, but I did a git pull on the main example OSS 2022 Zephyr app, example application, just a git pull. And that got me the extra patch. And from there, just West update, and that's it. Give people a couple minutes to get that done, and then we'll switch back to the gist. So I'm going to this one. In the meantime, installing the requirements. Just a little bit of feedback. Is that working for people, the git pull and the West update? It didn't help? Really? Can you who said that? Sorry.
Well, if you meant that you should do West update again.
Yes, correct. No, git pull and then West update. Git pull and then West update. Yeah. So git pull will, because we're doing the git pull in the manifest repo, that will give you the latest changes in the manifest repo. Yeah. Was it fast now? Yeah. Okay, good. All right, good. We should have done that from the start. Sorry.
What's the output? It's blinking with a red.
Yes, if you reset it.
Stops.
Correct. Yeah.
And then the reset doesn't do anything, only if you pull it out, plug it out.
Oh, yeah. Okay, that's normal though. Yes, that's normal.
It's working.
Yeah, it is working like that. So once you have it working now, okay, but first, before we get there, I'm just going to, the build instructions are simpler than the last time. They're just West build -b, NRF52 840 dongle _ NRF52 840, and then app. In my case, this setup.py. I don't know why it's taking so long.
You may want to change the name of the.
Yes, so exactly. That was my next thing, and for some reason. So let me. So if you already have the code, then before you build, please go into the example application where you already were that, and please edit app source main.c, or actually, no, sorry, it's in the config. So project.conf. There we go. So in this case, you can see config. I don't know why this is shown like this. Okay, it's because it's this one. I'm going to close this one. So you can see here the device name on line 11. Please put something that's easy. It has to be short because there's a limited space for Bluetooth device names. But this is for you to be able to find your own device. So in my case, I can put LED Carlos. This will probably fit. Limit is about, depends on what else is being used for the advertisement data, as it's called. But let's say, try to keep it under 12 characters or so. Okay, so once you've done that, then you build. Yes. Can you try changing that? It's in so app prj.conf. Yeah. So just to show you again, oops, prj.conf. Yeah. So the last line is config_bt_ device name. So just set that to something that makes sense to you, because you're gonna have to find it. Yeah. All right. Yes. Exactly. And now we build. Oh no, I need to activate because hold on. Let me just, in my case, let me start from scratch. ¿Cómo se va? Alright, see, just sorry, source, then there. Okay, and now OSS 2022 app, example application. Let's build -b. All right. So, if you've changed your the name of your of the Bluetooth the Bluetooth advertising data, that is that prj.conf again, prj.conf, you should be able now to compile and then flash again with NRF util, just like the last time. Second. There we go. Packet generate, and then util, if you serial, and then this is going to be yet another name. Oh yeah, I need to press the flashing button. Okay, there we go. This is longer this time because it includes the Bluetooth stacks, and so the executable is much bigger in size than the original one. So if everything has gone well, you should see the LED blinking with an RGB pattern for a few seconds, and then it will turn itself off. Okay. But the key thing here now is that, and unfortunately I don't have a screen sharing on my phone, but if you use the NRF Connect app, which is a free app on your phone, the NRF Connect app, you should be able to search for the device and change the LED color using the app over Bluetooth. So let me see.
Light blue would work better.
Well, yeah, you can use either NRF Connect or light blue, but I think probably NRF Connect it's easier. I think NRF Connect will work fine. So you should be able to see your LED name now on the NRF Connect app, hopefully. Yeah, so in my case, I see it here. I click connect. So are you finding the devices?
Yeah, that's mine.
You found it?
Yep. Okay.
For myself.
Did you connect? Can you connect to it?
I don't see myself.
Okay, it says connect.
Click on client. And then when it says LED button service here, you have a, so yeah, so just on.
No, it won't work. It's not a LED button service actually.
Oh, it's not?
No, it uses the same ID, but it's not. You
Oh.
need to use manual writes.
Oh, okay, so you have to click on advanced.
Right.
Request command.
To change the ID so that it
Why is that getting confused? The app confused then?
I don't know.
Okay.
But for Bricks it was working.
Yeah, and it worked for me as well. So this might be an older version of the app. Could it be or
No, no.
no? Okay.
It's,
All right, because it worked for me as well. Let's see.
yeah, you need to get into this menu. Otherwise
Yes.
it will not
So you
work.
need to get into a menu where you can write a value to it, and then it's an RGB code, like 3 bytes with RGB components, and then you should be able to write the component. And if it works better for you, because I see that some people are having issues with NRF Connect. There's a free app called Light Blue. It should be tiny and super light to download, and it's even easier to use probably. If you have any issues with NRF Connect, just use Light Blue. It should be available for both Android and iOS. And I very much recommend it. It's probably easier since I see there's some people having issues with that.
You can change the ID of the characteristics, and
Yeah,
then it
then-
lets you write your own number.
Yeah, that's
What I did.
How do you use NRF Connect actually?
Yeah.
I think it's better to just use like
Pero es que there's two services. Which one did you? Oh no, that's the CCCD. Okay, why is there none of the file? Right in the value, yeah. FF00FF.
Gerard?
Done.
So on the Android app, the NRF Connect Android app, you can only set a Boolean value.
Yeah, that's what we're using. I don't know why.
Oh, okay.
Because it's detecting the LED button service, which is a kind of standard internet
You're
CS.
using their own ID.
Yeah, I copied it.
Okay.
I was using Light Blue, so
Oh, okay. Sorry, should have checked it. 'Cause I bumped into it immediately.
Fabio, do you have Light Blue or NF Connect or
No,
both?
I have NRF Connect, so I had to change the ID to not use the LBS one.
Okay, I see. Can you try, Fabio? You have an Android mobile phone?
Yeah.
Can you try installing Light Blue? Just to make sure that it works on Android as well. Light Blue, all one word should be.
Okay.
Yeah, that's the one.
Then she's going to get it.
See if it's easier with this one.
Yeah.
I'm gonna just put it on the.
No, the NRF Connect. Because I had the ID saved in NRF Connect, so it would.
You can share it on the screen as well, I think.
How?
You want. It's you can do it like this. It's in.
I get some. Oh, okay, that's nice. All right, I managed to, or thanks to Gerard, I'm sharing my iPhone screen actually. Wow, that's nice. All right, so you can see here, this is Light Blue, okay? That, like I said, since there seems to be some issues with NRF Connect, this one works for sure, and it's available on for iOS and Android. So if I click on the one I just created, there should be a special characteristic, which is the one with the strange name here, or the strange sequence of characters. I click on that, and there's a write new value, and there I just click the 3-byte code, for example, for an RGB color. So for example, in my case, I want to do FF0000 to get red, and then done. And you can't see it here, but my LED is completely red now. And the nice thing is that it caches them as well. So if I now switch to say green, 00FF, and then 00 again, and now my LED is green, and I can switch between the two, red and green, by touching those. By touching those cached values in here, because it's sending them every time it's sent. So hopefully that should work. And with Lightblue, it seems very solid. The reason there's some issues with NRF Connect is that we reuse the UID for a proprietary service that apparently Nordic uses, so we use. So that gets NRF Connect a little bit confused. I didn't realize that. So so we discovered that here. So yeah. So that is the. Anyone need help with anything?
It's funny because on the iOS app it works fine.
How to change color?
So you have to write. You
yeah.
have to write FF. Who is it?
Bueno, yeah,
yeah,
I think it's, yeah.
Okay.
Okay, so now we can talk about the structure of the application if you want, so I will give some highlights. So we use example application, as Carla said. One of the reasons to use example application is because it allows you to do, or is it like how you would probably structure your application in production, because it allows you to have like, well, it's like an application skeleton. Oops, sorry. Let me go back. Okay. So the good thing of example application is that there is an example on how to do a custom board. This is something that you will likely do in your real project, because it's nice to work with development kits, but in the real world you will create your own boards. The other thing that you have in example application is that it shows you how to develop out of three drivers. The example applications comes with a sensor driver that I will show you, and this the demo that we are running today has a custom driver using the LED API that we will go through later. And yeah, it also shows some CI configuration using GitHub Actions, the same kind of the same way we do in Zephyr. Now it has a West extension as well. So yeah, it's kind of how you would structure like a real application in Zephyr. You have other ways, but I think this is kind of the most flexible, in my opinion. So today, if we go to the let's first open the application main.c, which is the application entry point. So it's in app source main.c. So the first, let's start with the main entry point. Yeah, so one thing that we haven't mentioned is that in this application we actually enable USB and we expose like a virtual serial port. So if you actually open a terminal application like Pico.com, or in Windows you have TeraTerm or one of those serial terminals, you will see some messages appearing in the terminal. It's useful for logging because this board doesn't have like any interface other than the USB, so it's quite useful. So this is enabling this board. So if you again open it, you will see the messages. And the next thing we do in this application is we first obtain a reference to the RGB LED. Now we will see how this is defined. And what we do first, and you probably notice, is that the first thing that happens is that you see the LED turning red, then green, blue, and some other colors, some basic colors. We are doing this using the Zephyr LED API. And after that, we turn the LED off, and we just enable Bluetooth and start advertising. Okay. When we start advertising, we have a callback somewhere here. Yeah, we have, yes. So again, if you open the terminal, you will see these messages when you connect your phone, like connection, when you hit connected, when you disconnect, and so on. And yeah, we define a custom, it's a custom service in BLE, and this is the callback. So it's basically a service that allows you to write hex value, so it's a color. So for example, FF0000 which is the color for red. It checks that the length is 3, so you have 3 bytes for the color. This is the offset that needs to be 0 in this case. And then it calls the LED API to set the color that we have passed via BLE. Okay, so it's pretty simple. And here at the beginning, we have all the boilerplate that you need to for Bluetooth. Basically, we define our service UID. Yeah, so that's I reused the IEDs, the UIDs from Nordic LED button service. Okay, I should have changed those hex because yeah, that's we are not really implementing that service.
That's what confused the NRF Connect app.
Yeah.
Thinking
Okay.
it was seeing something.
Yeah, that's my fault actually. But yeah, I mean, and Light Blue doesn't know anything about LED button service, so this is why it just works. It doesn't make any assumptions if it's a Boolean or if it's a color or whatever. Yeah, so this is the structural application, and one of the first thing before getting when I started doing the application, if you actually look at the Git history, just I'm not used to this touchpad of Mac, sorry. Yeah, so go to the commits. So I will go through the sequence when I develop this example. Yeah, so the first commits are really, yeah, some, for example, enabling the USB. So basically you have in the application for the, for the dongle board, we have an overlay configuration that enables the USB stack and, yeah, better, thank you. Okay. So yeah, for this board we enable USB, as I said, and we define that the Zephyr console is actually going through the CDC CM device that I just defined in device tree. Oh, it's natural scrolling as well. Okay. It's really confusing. And then yeah, we just enable USB at main. So what this patch does in this case is basically to have this virtual serial port, so you can print K and see what's going on in the. It's useful to debug because otherwise you need to get J-Link or yeah. So I didn't have the J-Link connector, for example, and I was struggling to debug. So okay, let's first start defining this. Okay. Then the next commit. Okay, it's really, really confusing. This Mac. Yeah. So then the next thing is that this board, this example application, comes with, as I said, an example sensor, an out-of-tree driver. So I just remove all this because we are not using this code, so nothing relevant here. So we have like a clean main, okay. And then yeah, so the one of the important parts of the application is the custom out-of-tree driver. In this case, I decided to implement the LED API. So in Zephyr, you have if you go to the upstream repo. So actually, let's open it. Zephyr, it's this one. No. You have it cached. This one? Yeah. Okay, so if you go in Zephyr, in include Zephyr drivers and open led.h. So this is an API that's built in Zephyr that basically allows you to control LEDs. And if you look at the interface of the API, it starts here at this point. Yeah. So yeah, it has the option to blink. It has the option to get LED information, to set the brightness, to set the right channel. Well, if it has a few calls like set channel, set color, which is the relevant one here, and then the turn on and off. So I thought that this is the API that fits better to implement like a driver for an RGB LED using the Zephyr device model. Okay, it's quite complex. It's quite more complex. So you can have like it's multi-channel by default. You have this. I mean, yeah, with the driver that I implemented, it's not really matching the API specs, but to keep things simpler, really. So, but it's not implementing all the calls, for example. This get info is not implemented, the blink is not implemented, so it's really just implementing the on, off, and set color. That's it. So it's not really API compliant, but I think it's enough for the example. And so yeah, so the first thing that we do in the out-of-tree application is to add the folder structure to add a new LED driver. So yeah, if you look at the yeah, maybe I can open it in another tab so we can. Oops, just open here. So you see that in the application folder we have in the same way as in Zephyr, you have the drivers folder. Here we have LED folder, which means for LED class drivers. And here we have the same structure as in Zephyr. We have the main kconfig. So here we include all the implementations, like in Zephyr. Here is the kconfig specific for the LED RGB, our implementation. Okay. And then we have the actual implementation of the driver, which is in this file. Okay. So we don't have much time today to explain how Zephyr driver works, but there is a presentation from the Zephyr Development Summit that goes into a lot of detail on how to implement drivers, how you structure the folders, and so on. But the idea here is that, so first, let me open the device tree part. So in Zephyr drivers, let me open another tab. So one of the things that you need to do first is how you describe your device in device tree. So we need to define the binding. The binding is the actual schema of what is in device tree. So it tells you if you have this entry in device tree, what are, for example, the required fields, what are the expected properties, what are like their default values, and so on. So for the LED RGB, we have a binding that looks like this. We define the compatible. It doesn't have any vendor in this case. Like, for example, it could be a sensor and so on. So it's just LED RGB PWM. The reason is because, well, this is an RGB LED control using PWM signals. We include LED controller. It has some like, we can reuse some of the properties from the standard LED controller bindings. And in our case, what we need really is an entry for the PWM signals, and we also use names in this case, because in the driver we will see that we retrieve the entries using name. And this, the binding includes an example on how it is expected to be used. So you just would define an entry in device tree, random name. Here I'm using LED RGB. You add the compatible. This matches with the binding. So device, you know that your device tree parser kind of knows that, okay, this node has this compatible. I know that I need to go into this binding, and then I know which are like the available properties, the specification basically. And it also expects 3 PWM channels. So in this case, for example, the PWM controller, channel 0, the default period. This is kind of a standard for LEDs, 20 milliseconds or 50 hertz. And in case you need to change the polarity, like it's the case in this board, it's reverse polarity. And then you just say, okay, for the PWM entries, the first one corresponds to the red LED, for the green and the blue. Okay. Then how does it look like in the real board? So if you go into the application, we have an overlay in the boards folder for the dongle, which is this one. And if we scroll down, we have this entry here, which is kind of the same as in the example, really. I just had to change the polarity because this board it's inverted polarity. And important thing is that I am adding here a node label, which will allow me to get like a reference to this to the actual device in Zephyr. So that's quite common in Zephyr, that you will see that most of the device tree nodes have a node label, because that's the most I would say popular way to obtain a reference from device tree.
So this is the board definition, right? And the previous one was the app definition of the reference to it?
So the previous file was the binding. Okay, so in a driver you have in a device tree based driver, okay, which are like most of the drivers in Zephyr nowadays. The binding tells you what. So for example, this is device tree. So device tree itself doesn't know anything about your devices. So you need to tell, okay, when you find an entry with this compatible, you should, for example, require this property. This is like the default value. This is the maximum. I mean, all this kind of information. It's because if, for example, you write an entry in your device tree and you forget about the PWM's entry, device tree will say, hey, this doesn't work because PWM's is required, for example, and you will get a build error. Okay. And this file is actually the board overlay. So this is getting like put on top of the original board DTS file, because it's not like defined upstream. So it's kind of extending the upstream board. If you have like a custom board so for example, you have like developing the board entirely downstream. So like the custom Pwm example we have here. So we have this board here. You could actually define the LED here, and you don't need then an overlay, because it's like it's always there, this LED, and you know that it's all, it's like overlays are useful for evaluation kits because you don't know what it's like flexible. You can plug, for example, a shield or stuff like that. So overlays are really useful. But in the real board, they are not that useful, or like kind of more not. Yeah, that's. And now we can go to the driver file. As I said, let's go to the code. Drivers, LED, and yeah. So this is the actual implementation of the LED driver. Okay. One of the first things that you will find in most Zephyr drivers is this DT, the driver compat definition. Okay. This is kind of what this is to make it simple. That says, okay, this file is implementing a driver for this device tree compatible. So when you have in the device tree LED-RGB-PWM, this kind of the link between the driver and device tree, just to make things simple. Okay. So yeah, this is like the what creates instances of the driver. We have this macro here, the device int define, and what this block here does is for every entry I have in device tree of this RGB LED PWM, it creates a new instance of the driver. So we could have, for example, 4 or 5 RGB LEDs, and this driver would create an instance for each of the devices. And then in your application, you can use the entry one based, for example, using the node labels or whatever. And the way it works here, I mean, in this case, it's pretty simple. Okay, we are just, I mean, all the drivers kind of follow the same pattern. You have like the data field. The data field in drivers is mostly for data that it's modified at runtime. For example, it could be like a queue, matrix, for example, that you need to change, or a buffer or something that basically is modified at runtime that goes into RAM to make things simple. And then there is another part, which is the configuration, which is typically in device tree drivers information that comes from device tree. You just store it, okay? Because in Zephyr, device tree is something that it's only exists at compile time, okay? Not like in Linux. So here, what I'm doing in this example, in this case, is like, okay, I'm just storing what is in the red entry in device tree. So I get the PWM GT spec. This collects all, like the controller, the channel, the default period, all the information is using this macro. That's quite useful. And here I'm saying, okay, for the red entry. So this is why I need these red, green, and blue names in the PWM names properties. Okay. And basically storing all this information. And then I define the device, which has an init function. This is the pointer to the data, the pointer to the configuration, init priorities, and so on. In this case, the init function is really simple. We are just checking that the PWM devices are ready. So that means that they have initialized successfully. That's something that you need to do in Zephyr, otherwise it's kind of undefined what happens with your device. So just always do this, okay? You will see this function all over the place. And here we have the actual API. As I said, this driver is not really compliant to the API if you check the API specs, but it's served for the example. So what we have here, for the on function, we just setting the color because it's like turning on sets the PWM channel, so it's like not really useful here. For the off, we are just basically setting the PWM periods to 0. That turns off the PWM. If you look at the PWM API. And then in the set color, we are just checking, okay, that I get 3 colors. I'm just caching the values because then when I turn on, I get the same value. If I turn off and turn on again, okay, that I don't lose the last color. And then I just set the PWM pulse. I mean, in an RGB LED, probably but it's really easy to control. You just set the PWM signal for each channel, and then you basically change the pulse width to adjust the color. So if you have like a full pulse in the red channel and 0 on the others, you will get red. The same for the other. And if you like have, for example, 50% red, 50% green, you will get like the proportional color. So what we do here is set. I get for the PWM period, which is specified in device tree, if you remember, these 20 milliseconds. I basically multiply the color I get from the API call, and I divide by 250. Well, this is the UNT8 max, which is 255. So I get like the proportion between the color I get and the maximum, okay, according to the period. And the driver, I mean, it's fairly simple. So it's like, yeah, the question is whether it's worth to have a driver for an RGB LED, but drivers can get quite complex. So I think that's the example really. And with this in place, let's finish with what's in the application itself. Let's go back to the main source main. Oh, maybe just one last thing. In the application, in the project.conf, which is, I like kind of the default kconfig options that get enabled. We enable the config LED so that we get the LED subsystem enabled because we are using the LED API. So in Zephyr is config LED that enables all the LED class drivers. And because in device tree we have our RGB LED enabled, it will just automatically build that driver as well. And in the source main, just to finish, so what we do here, sorry, it's at the top, it's here. So we have talked about how to define the device in device tree, what are the bindings, the driver implementation. So now from an application perspective, how do I use that LED, okay? So you basically need to obtain a reference to the RGB LED device instance, and there are you basically need to use device DTGet. There are some other variants of the device DTGet if you look at the documentation, but you need to provide one kind of node identifier. One easy way is to use node labels. Node labels, if we go back to the application overlay, it's this thing here. This is the node label for this device tree node. Okay, so that means that from this is I can use this from the application basically. So I can use DT node label RGB LED. I know that I will get a pointer to the device that it's implementing the driver for that device tree instance. And from now on, what I basically do is, okay, let me check that the device is ready, because in this case it's always true because the init function never fails, okay? But some drivers actually fail. So in the init function, you do some checks, and okay, if it fails, then I return an error, and the device is never ready because it fails, for example. So you need to do that in your application, okay, just to be safe. And then I just use the API. So just setting the color, I provide the pointer to the RGB LED. The channel is always 0 because this driver is not multi-channel. I'm providing 3 colors and just have here the color. So you have this red, green, blue, and so on. And finally, I turn the LED off. And as I said, this enables Bluetooth. And in Bluetooth, I'm just calling really this API again to set the color. So just some remarks to finish. One of the good things about using Zephyr, the Zephyr device model, is that you always use interfaces. So here, as you can see, I'm using the LED interface, and I pass a device pointer. But if I need to test this code, for example, it's really easy to implement for example, a mock driver or a mock device or a simulator or whatever that is an RGB LED, and I can run this application on top of, or for example, on POSIX or in Linux, and I don't need the actual hardware, for example, to test this code. So that's something that's really useful, because if you are like start hard coding or calling the HALs directly, good luck with testing. Okay, that's you will have a hard time basically. With interfaces, you have a little bit more overhead, but you have these facilities that you are kind of isolating stuff in layers. And I mean, it's been pretty quick, but there is a presentation from the Zephyr Development Summit about drivers. I mean, it covers all the details and why things are done like this, and how you structure the folder, as I said. And that's, if you are interested, really look at that presentation. It's I think it's a 2-hour presentation, so it covers
the Zephyr YouTube channel.
It's in the Zephyr YouTube channel, yes. So you can search there. It's mastering Zephyr driver development, and that's, in that case, it's developing like a lock driver using PWMs, ADCs, and so on. And I think that's all. I don't know if you have any questions, guys.
You said you only implemented the portion of the LED driver, right?
Yeah.
So what happens if an application tries to call an API call that you haven't implemented? Is there like a default implementation or?
That depends on the API. So, for example, in the case of LED API, we can go to the Zephyr repo. This is Zephyr, yeah, this one. Let's open led.h. So where it is? Okay. So, yeah, some APIs are better documented than others. But here, if you look at the API calls, it says, okay, these are mandatory callbacks. So at least you need to implement on and off, okay? And these are all optional. So if you look at the implementation, what happens in practice, for example, the let's blink, okay? What happens is if the call is null, it returns InnoSys, which this is the error code that we use when the function is not implemented. Okay, so your application will not crash basically. But if you don't implement the on, for example, here, it assumes that it's not null. So if you have it null, it will crash your application basically. Yeah.
Okay.
Any other questions? No. Okay, so thank you.